Hello, everyone. So we have another AMC 10 problem. So this was number 23. So the zeros of the function f of x is given as integers. So this is going to help us be in the integers. And the sum of the possible values of a is what we are looking for. A is like the coefficient of the linear term as well as like the constant term as well given in terms of a. So when you are given somehow relation between the roots, which means like zeros, of a like function, even a polynomial with the with the coefficient, that's a good job for the Vieta, right? So, and if you don't know the Vieta's rules, Vieta's like relations, so it's good to review those as well. So basically this, when you add this solution, which I'm going to call x1 as my first root and x2 as my second root, when you add the roots of a quadratic, that will be equal to negative version of the coefficient of the linear term. So that's going to be negative of negative a, which is going to be just a, and divide by, I actually need to write this, negative b over a. So this a and b coming from this general form, ax squared plus bx plus c is equal to 0. So you take this coefficient, in this case, coefficient of the linear term is negative a, so you take the negative of that. Okay, and then divided by coefficient of the quadratic term. In our case, it's just 1, so that is nice. And this is equal to a. And similarly, product of the roots of a quadratic is going to be a constant term c divided by coefficient of the linear term. Coefficient of the quadratic term. So the constant term in our case is 2a, the term that has no x, divided by coefficient of the quadratic term, which is 1. So that will make us to get 2a. So now we have like two equations. The sum of the roots is equal to a. The product of the roots is 2a. So I just want to kind of solve the system. So for x and like x1 and x2 or a's, since we are interested in sum of the roots, so I'm going to just find the x1 plus x2, which is our a's. But we have 3 variables and 2 equations. So it's not usually enough to solve the system. So what I'm going to do, I'm going to multiply the top equation by -2, okay? Because if I multiply this by -2 and combine with the second two, the a's will cancel. So we end up getting like x1 times x2 and minus 2x1 minus 2x2. And then this is equal to 0 because a will be added up to 0. And now we have like a product of the 2 variable as well as those 2 variables as given as a linear term in the same equation. So whenever we have such a thing, especially if you are interested in integer solution, so we have something we call Simon's favorite factoring trick. So this is another tool that we use when we are trying to deal with some integer solution or equation, especially when you have like 2 variable with the product as well as the linear term. So you can use a sum with more variable and even with higher degrees and stuff, but usually this is what we have. So now I'm going to try factoring. So that's what we do with like Simon's. So if you want to get the product x1, x2, so I'm going to take x1 from first parentheses and x2 from second parentheses so we can get product, and the change order doesn't matter. So if I want to get -2 times x1, so I need to multiply this number by the number right here. So that should be -2, so we can get this term. And same reasoning, x2 times this number should be -2x2, which is going to be -2. But when you multiply these, you actually end up getting another term, which is -2 times -2, which is 4. But that wasn't part of the equation. So we cannot really have this factor unless we add 4 to the left side, which we cannot change the question. But if you add the 4 to both sides, so that will be okay. That is called Simon's favorite factoring trick, because adding something or subtracting something so we can factor is called, this process is called Simon's favorite factoring trick. So now we are given product of 2 things is 4, but we are lucky because x1 and x2 are the roots, and then we are told the roots, like the zeros, are integers. So if this is integer, 2 lesser is also integer. So each product is integer. So you just need to look at the divisor of 4. So we can have 1, 4, I can have 2, 2, I can have 4, 1, and then I can have the negative version as well because integer could be negative as well. And then I can have -2, -2, and then -4, and -1. So these are the H product, but these are not my x1 or x2s. But at the end, we are interested in sum of the x1 and x2. So based on this, like if I want to kind of make a like table, just organize my work, I wouldn't do this on the test, but it's good to kind of do it. Maybe it's better to do on the test as well if you're kind of stressed with losing some of the information you have. So it's still good. Okay, so then I'm gonna say this is x1, this is x2, and then this is gonna be x1 plus x2, because this is what we are interested in, because a is the sum of the roots. So the x1 minus 2 is equal to one of these numbers. If you add 2 to all of these numbers, you get x1, which means that will be like 3. So 2 more will be 4. You get 6. So you get 1, negative 2 plus 2 will be 0. And the last one is -2. And if I add 2 to these guys, so you got 6, like 4, 3, -2, and 0, and 1. So the problem is, like, when we say the sum of the roots, like this is going to be 9, which is good. This is 8. This is also 9. That is -1. This is 0, and this is -1. So, you know, we have 2 9s, right? So we shouldn't be taking those 2 different 9s, because actually, like if we take that 2 different 9s, right? So it will be counting the a twice, because we are interested in some of the a's. A is just the sum of the roots, so sum of the roots will be 9. That means a is 9, but this is also a is 9. So you just take 2, like a is like 2 different number, which is not the case. So you just take one of them. So if I take this, same with the -1. So that is 17 minus 1 is 16. And if you try to add all these like repetition, so there is no choice like that, which means the question writer was kind of like nice to us actually, because that would be the bad idea to choose that choice, because we cannot have the same numbers twice. Okay. So anyway, so that was the a question, just testing our Vieta approach and a bit some factoring. So I hope that was useful. And if you like to look at these, I'll add a few maybe reminders, maybe a bit practices about these 2 topics in the description, so you can take a look at those if you like practice more. Okay. So anyway, see you next time.